Alright, big topic today, properties of logarithms. And these really are going to help us simplify expressions, solve equations coming up in the unit. So really want to feel good about these. So three big properties let's look at. Now, for these to be true, let me back up. These apply to any base. Okay, so on this slide, I wrote natural log just because that was less letters to type. But it applies to any base of logarithm, okay? So a and b have to be positive numbers. N for our power has to be a real number. Then these powers are true, or these properties are true. Product property. Of course, product means multiplication, right? So if you've got the log of something multiplied, you can break it up into a sum. Log of a, log of b. Now these are natural log. I'm just saying log here. Quotient. Of course, that means division, right? So natural log a over b. Break it up. Very similar, right? Here they're added for product. You just subtract them here. And then, of course, power properties. So we've got something raised to a power. This is a really cool property. You can just bring that exponent out front. That helps us solve equations. Again, we're going to see a lot more of that in the future. Let's go look at some examples. Expand each logarithm. Okay, so this wants us to take the log and expand it. I did a couple with numbers and then some that have variables in them as well. If I can find my cursor here, there I am. So expand each logarithm. So let's write this thing out. We've got multiplication, right? So I could write this as log base 6 of 12 to the 6th plus log base 6 of 5 squared. And then one other thing, I could actually bring that exponent out front. So 2 log base 6 of 12 plus 2 log base 6 of 5. Sorry, that's not a 2. My exponent was a 6. So we'd bring a 6 out front there. Sorry about that. How about this one? Okay, now we've got division, don't we? Now we do have a 2 in here. And so let me just rewrite this. Let's put the 2 right there. And let's put an 8 right there. Okay, if we go ahead and apply that. So now I could separate log base 5 of 10 squared minus log base 5 of 7 to the 8th. And now same thing, we could just bring those exponents out front. And so 2 log base 5 of 10 minus 8 log base 5 of 7. Okay? Now how about these ones that have only variables in them? Same principle applies, okay? So here we've got division, and so I can take this 4 and put it inside, and so let's put a 4 right there, a 4 right there, and that would become an 8, okay? And now let's separate things out. So I've got log base 8 of x to the 4th minus log base 8 of z to the 4th minus log base 8 of y to the 8th. Now these are both minus because they were both on the bottom down here. Then one last step, bring those exponents out front. So 4 log base 8 of x minus 4 log base 8 of z minus 8 log base 8 of y. Again, hopefully you're seeing the pattern. Hopefully that's kind of making sense. You do a few of these, you can kind of do them a little shorter. I'm trying to show the steps so you feel good about them. Okay, how about this one? So we've got multiplication, we've got a cube root here. So let's think about what we've got going on here. So we've got log base 5 of c plus log base 5 of d plus, now what's a cube root? Couldn't I just write that as a 1/3 power? 1/3 power. Get rid of that cube root. So that would be log base 5. I'm going to run out of room. Sorry about that. A to the 1/3 plus log base 5 of b to the 1/3. And then, of course, you can see what we're going to do. We just bring that 1/3 out front, 1/3 out front, and that would be our final answer there. Okay? How about if we go the opposite direction? What if we want to condense expressions? So we can go either direction, and there's situations where it's going to be valuable to go one or the other way, just kind of depends. So same thing, I've got some expressions with just numbers, then I've got some with some variables here. So condense each of these. So notice, these are all to the 1/2 power. So I could just rewrite, think of the 1/2 out front, which you could then put as an exponent. So this would be the same as log base 6 of 2 to the 1/2 plus log base 6 5 to the 1/2 plus log base 6 of 7 to the 1/2. Well, these all have the exact same power. And what's the 1/2 power? So if I did like x to the 1/2, well, that's the same as the square root of x. Okay, so I could put all these under a radical. So this could be log base 6 of, now these are plus plus, so 2 times 5, that's 10, times 7, that's 70. So square root of 70. And that would be my answer there. So notice we took that and combined it down to a really much simpler expression. Okay, how about this guy? Well, we could take this 5 and put an exponent right there. And 1/2, can I get rid of that? I could put a square root right there, right? 1/2 in front, 11 to the 1/2, same as square root. And so I've got log base 7 of 3 to the 5th times square root of 11. Now, 3 to the 5th, I don't know, I'll just leave it like that. You can go put that in your calculator, whatever that number is probably the way we'd write it, okay, to simplify it. But there we go, it was add, so we just combined them there. How about these guys again? We've got our variables in play. So exponents, going to come over here, no exponent there, got a 2 there, okay? So I've got log base 6 of x to the 6th over, now I know it's over because these are subtract. I've got z y squared. And if you want to put parentheses here to remind you that's log of all of that, we could do that. Again, why are both these on the one? Because they're both subtracted, okay? How about this guy? Now we've got add, so these are going to be multiplied. So my 3 is going to come up here. Now I've got 1/2 in front, 1/2. So that's square root. Hopefully you're seeing where that's coming from. And so log base 5 of w cubed times the square root of uv. Hey, there we go. Okay, so again, write these properties down, keep them close as you're going through. We're going to use these a lot, and so we want to feel good about them.